The next lesson plan we'll be talking about is all about surveying the sea. Have you ever thought about what the ocean floor looks like underwater? I think most people, like myself, will probably think that it's nice and sandy, but it's nothing like that. When we look at the surface, we have mountains, ridges, things like that. We have all these same structures underwater as well. So there's mountains, canyons, ridges, all of these structures are there. So if we want to do work underwater, if we want to build a bridge, if we want to lay pipelines, we need to know what it looks like underwater so that we know the kind of terrain that we're dealing with. Now, scientists have developed different techniques that they can use to look at the underwater world. The main surveys that they use are to do hydrotechnical surveys, which use sonar mapping, sound waves to detect depth and to detect the kind of surfaces that are down there. There's also a slightly different type of survey, the geotechnical surveys, where you can take samples underwater to see all the different layers, like taking a core sample above water that people have seen done before. It's similar to that, so you can look at all the different layers that are underwater. And also in the oil and gas industry, they often do seismic surveys. And these surveys are aimed at locating gas or oil pockets underwater. The way this sonar mapping works is you have a seismic ship, and at the back of the ship there's a big cannon that can make a sound. And then in a long train behind the ship there'll be hydrophones, so it's microphones underwater, we call them hydrophones. There's a long train of hydrophones trailing behind the ship. So when the ship makes a big sound, sound waves travel down underwater and they get bounced off the different surfaces. The hydrophones behind the ship then catch this sound as it's returning, and fancy computers on board will collect all that data and will come up with a map of the ocean floor. So that's very simply put how we discover about our underwater world. So we'll then move on now to try some activities that we can use to teach our pupils about sonar mapping and how we survey the sea. The first activity we'll be looking at is all about sonar mapping and how we can teach this to our pupils. In this activity we'll be using a bouncy ball to mimic the sound waves. So you can imagine sound travels down underwater, hits the bottom or hits the ocean floor, bounces back up, and then is caught by the hydrophones. We can use a bouncy ball to mimic that. If we drop the bouncy ball from different heights, it will take longer for the bouncy ball to travel back up. So the longer it takes, the deeper the area must have been that we're measuring. So you can get pupils to drop the bouncy ball from different heights, sitting down, standing up, if you have a staircase, from a staircase, and time how long it takes for the bouncy ball to drop. It's important here, your bouncy ball might not always bounce up all the way, so what you can do is just time the time it takes from the bouncy ball when it leaves your hand till it hits the floor, and then double that time to get your total time. So you can do that and get pupils playing around with this just to get the idea in their head that the longer it takes for a sound to travel, the deeper the ocean floor will be. Then a second thing you can do is, we talked about seismic surveys and trying to localize oil and gas pockets. In order to do this, scientists know about the types of rocks that oil and gas are most likely to be found. And when sound bounces off different types of rock, different surfaces, the pitch and the amplitude of the sound changes in different ways. Again, we can mimic this using our bouncy ball. So if we bounce our ball off the table, it will bounce different than when we bounce it on a tray, or when we bounce it on a tray with some sand on it. So this is just a really simple activity you can use to show that when sound bounces off different surfaces, it will impact the sound differently, and hydrophones could pick this up and could then give us an idea of the type of rock that we might find underwater. So get your pupils, get kind of creative. You can use pebbles, you could use a tray of water, you could use bubble wrap. You can have different surfaces for pupils to bounce the ball off and get them to record how it affects the sound as it bounces. So that's really getting pupils to think about sonar mapping. And then the next activity in the lesson plan is getting them to create their own sonar map. And in order to do this, you can make a shoebox, and in this shoebox you build a scene, an underwater surface area. So you can build mountains, ridges, whatever you do. So what I've done, I've pre-made a box here with some surfaces in it that I can show you. So there's a little mountain here, and there's some bits there. So I've just used plasticine to build the box. If you did this activity in class, you could either pre-build the boxes yourself, or you could just get groups of pupils to build their own box and then pass it to another group. Once you build the box, close it off, and you can put a grid on the top. So I've just labelled it A to H, I think, and 1 to 5. So you've got a different grid over which you can sample. So this is similar to what we do in sonar mapping. We sample in different locations to get a complete idea of the ocean floor. So once the boxes are created, you can use skewers to sample at different locations. The easiest way to do is if you can get pupils to mark the skewer with a ruler, so 1 to maybe 15 centimeters. Most shoe boxes are about 12 centimeters deep, so if they mark up the skewer, and then they will measure at each location, they can measure the depth. And again, this will mimic the deeper it is, so the longer the measurements, the deeper the ocean floor will be. So get them to sample all around the box, and then they can start to create their own map. So with the lesson materials, you can also print out these sonar map templates. They're all available with all the other materials. So when pupils have taken their measurements and filled it out, you can then colour in the different measurements. The easiest way to do it, if you colour, just take 2 centimetre increments. So anything between 0 and 2 centimetres would be red, between 2 and 4 would be orange, etc. So I've made a little sonar map for our box just earlier. So when we see our box, it looks like that, and our sonar map would look something like this. Once pupils have done this and they've created their sonar map, they can look in the box and see how accurate their map is. And then it's important to kind of discuss what they could have done to improve on their map. Because obviously, we've only sampled about 30 times. What would happen to your map if you sampled more locations? Also, what would happen if you had more colours, so that you could have a smaller scale over here? So there's different ways in which they could improve their map that are good to discuss with them. So this is a really good activity that looks at coordinates, and it gives them a really good idea of how we can investigate our ocean floor. I hope you enjoyed that, and I'll see you in the next video.